TI Launchpad.
Can't you see I'm busy here?
Don't be held hostage by the board order. Go to digikey.com to find thousands of boards in stock, all ready for immediate shipment.
Hey everyone, welcome to the March edition of Make Live. This is part of our Skillbuilder series. I'm Tyler Weingartner, video producer at Make Magazine, and normally I'm joined by Make Magazine's photo editor, but this month is a little bit different.
Yes, I am no longer the I'm still the photo editor of the magazine, but now I am also the social media person behind all of the Make social accounts. So when you talk to Make on Twitter or Facebook or Instagram, you're probably talking to me or Tyler on YouTube.
Yeah. Also, this is HEP.
Also, yes, I'm still HEP. Same great HEP, new role.
Yeah. So anyways, Make Live is the series where, well, we don't just build stuff anymore. We also deep dive into some of the skills that you need to tackle projects that either we build live or you need to build in your next project. And of course, this series is made possible by our good friends at DigiKey Electronics. If you're not familiar with who they are an electronics distributor based here in the United States. They have and sell everything that you need to build your next electronics project, whether it's a discrete component like an LED or a diode or resistors, all the way up to single board computers like we're working with today, the Raspberry Pi. Anything you need, they sell it, they ship it fast, and they're great partners to work with. And we're super lucky to have their support with this series. So as I mentioned, this is part of our Skillbuilder series. This is sort of the half step between projects that we do where we deep dive into skills related to the project that we're going to be building next month. And the Skillbuilder today is based on this little guy, which is the Raspberry Pi single board computer. And we're going to take a quick look at it and get the tabletop camera here ready. So we can get a close look at it. Let's see all the cool bits on it. This camera turned on. Get it focused and all that good stuff. And all right, so this is, as I mentioned, the Raspberry Pi, and it's a computer. I know it doesn't normally look like a computer, or at least what you normally think of as a computer, but it's got all the things here that you would normally get in a computer. or at least if you grow up building your own PCs and have a it's not like a laptop or something like that. But so what's on here? Well, these has the probably most important part of a computer, which is the CPU. That's that bit right there. I'm probably going to get some of the smaller components and indicating them wrong as far as like I'm sure the memory is on here somewhere, the RAM. I wouldn't be smart enough to indicate exactly where it is. Other important stuff is where you power it. It powers off of a standard USB micro. So any like USB charger, like a 5 volt. This is the Raspberry Pi 3 B+. It requires a 2.5 amp power supply, so a little bit more specialized there. We're going to be talking about the different versions of the Raspberry Pi in a moment. It has HDMI out, so you can display it on a modern TV or computer monitor. If you have an older TV, you can also use this port that looks like an audio jack. This shot is looking a little bit dark. Let's brighten it up here. But this is what they call not a TRS, but a TRRS. And so if you have like one of those video breakout cables, you can plug it in there. You can plug this into an old television. Looking around at the other side here, get this focused up.
All the ports.
Got the 4 USB ports, and you also have the Ethernet jack here. If you want to plug it into, actually hardwire it into your internet. Up here, and very bright and out of focus, is the antenna for the wireless stuff. Pretty sure that's what's under there. So that has Wi-Fi radio, and what's new in this version is it'll connect to both 2.4 gigahertz and 5 gigahertz Wi-Fi, as well as Bluetooth. You have 2 of these identical looking ports. This one here is a ribbon cable port for various displays you can attach to your Raspberry Pi. We're not going to be working with any of those today. We're just going to be using the HDMI output. And also here is a port for, you can add a camera. We'll be taking a look at the camera a little bit later on. And other important stuff to know about this is on the underside here, it's easier to see the SD card. And this works as your hard drive. So you just, there's no onboard storage here. It's all in this SD card here. And we'll talk about how you get your software on there to get started building new software on your Raspberry Pi in just a moment. And then the last thing to take a look at here is this row of pins up here, which is GPIO, which is general purpose input and output pins. So this is where you can use hardware to interact with your Pi. You can attach things like buttons, so you press a button and have it do various computational things. You can have it light up LEDs. There are a couple of external displays, like the OLED display you can attach to it. There's all kinds of cool stuff you can do with these pins up here. We're going to be playing around with those in a little bit. But in the meantime, this is actually the newest version of the Raspberry Pi family. We have a little bit of a family tree here. We should actually start with, I think this was the first one. Pull up an image here. Nope, wrong spacebar. So what you're seeing here is this is the Raspberry Pi Model A.
A plus.
A plus. And so this is the first version of it, and it has most of the same stuff I just covered. It only has, it's hard to tell from this top-down view if it has only 1 or 2 USB ports. It is missing the Ethernet port. So if you want to attach this to a network, you will need a Wi-Fi dongle or something like that. Also, I forgot to mention, if you have any questions, please ask them in the chat, and we'll be monitoring that and making sure that we catch any questions that you have and doing our best to answer them. But carrying right along with the Model A, you still see it has the all the GPIO pins. It has, I'm trying to remember which CPU. I think this had the single core, maybe 0.7 gigahertz CPU. I'm probably remembering that wrong. I've never actually worked with this model of the Raspberry Pi. And then moving on, we have, this is the Raspberry Pi Model B. And this was a goofy one. Let me back this out a little bit because it is, we're not seeing quite all the details. Apologies for the shaky camera while I get this reset. So this is the first Raspberry Pi that I ever worked with. It has a lot of the same stuff I covered. It's arranged a little bit differently. It has fewer GPIO pins. On this side, you see it has this RCA video out jack. This is just a TRS, so this is just for analog audio if you want to use that. Still has the display and the camera ports. It only had 2 USB ports, so that was pretty limiting, especially if you needed to attach a keyboard and mouse, because you would basically be out of ports at that point. Or a keyboard and a Wi-Fi dongle if you didn't want to use the Ethernet. And this one has, get a little bit more in frame, it has an antenna. We'll figure out what that's for later. And the next one we have here, this is, which one is this? I'm looking straight at it.
Raspberry Pi 2 Model B.
Okay, so this is the Raspberry Pi 2 Model B. And this was pretty much all the form factors of the Raspberry Pi has been like this. There was a Raspberry Pi B Plus that had pretty much the same specs as the one we just talked about. But then it adopted this new form factor, which had the greater number of GPIO pins, the greater number of USB ports, and otherwise this layout's been pretty much the de facto standard for the Raspberry Pi since then. This one was a big leap forward in computational power. This had a quad-core CPU, a much faster CPU, and this was where you can actually start doing some really significant computation on this device. Still nothing close to what you get on your desktop. This pretty comparable to like what you might find in a cell phone from a few years ago, but still not bad for. And here's kind of the best part about the Raspberry Pi is its price. They're pretty much always at $35, which is cool.
Very decent.
Yeah. They have some weird stuff. It's sometimes difficult to find it at that pricing, and there's a specific reason for it, and that's because Raspberry Pi is made by a nonprofit organization. And so there's very few sellers that sell it at that price because other people who want to sell it, they want to sell it at a profit. Right. So usually you'll find it bundled with other stuff, and that kind of raises the price. But empirically, the price of the Raspberry Pi should be $35, except for when you're dealing with this guy. This is the Raspberry Pi Zero, specifically this is the Raspberry Pi Zero W. And so this is originally it sold as the Raspberry Pi Zero. This was the $5 computer. And they'd stripped down a bunch of stuff from the original Raspberry Pi. The original one didn't even have this camera port. And this is a slightly different camera port. You need a special cable to attach the Raspberry Pi camera. It still has the USB in for power. You only get one USB out port, and it's, again, one of these USB micros. So you'll need a USB on the go if you want to work with this directly, plugging it into a monitor. Speaking of plugging it into a monitor, they shrunk it down.
HDMI micro, right?
This is the HDMI Mini, I believe. Yeah, that's the Mini. Still the SD card. And the other cool thing is that you can still use an analog display. I believe so. Yes. There's these. Get a closer look and get
real in there.
You can still wire up your own RCA cable and analog. I think this top pin is for analog audio as well. So you can still do your analog audio and video out if you want to. And while it doesn't have the header pins, it has these rows for them. So you can go ahead and solder on your own header pins, but if you don't need them, you can keep it nice and slim. In fact, I just finished up a project with this one, which is a nice little in-car dash display, and I just soldered the display directly to these these pins or to these holes just to keep it as slim as possible. Because if I added the header pins, it would have added a bunch of bulk. The extra important thing about this is this little array down here. This is for the Wi-Fi antenna. That's what changed this from the Raspberry Pi Zero to the Zero W. It also raised the price from $5 to $10, but still $10 for a computer is not that bad. I believe this also has a single core CPU. I think it's 1 gigahertz. So it's not as computationally advanced as the higher end Raspberry Pis.
But it's got that slim package, and if you run that headless, you basically have something that's less the size of a credit card.
Yeah. In fact, on my 3D printer at home, I use this using a software we'll be talking about, but not showing as much later on, called Octoprint or Octopi. And basically, this is also the camera that lets me monitor my prints as well as acting as the print server. It's really cool software. I'd advise you all to check it out if you're into 3D printing after we're done talking about the Raspberry Pi here. All right. And that's sort of the world tour of Raspberry Pis. Come back to us for a little bit here. At least that's all the ones that we have here today. There's a couple of different models. They've been steadily evolving. Like I said, the Raspberry Pi Model B, Raspberry Pi 3B Plus, that just came out only last month. And it had a couple of incremental features. The Wi-Fi speed was a little bit faster. Let me get this camera out of the way for now, because I don't think we're going to be needing it too much. Because mostly we're going to be looking at the software directly on the Pi.
Before we jump into that, though, Jeremy wants to know what the in-dash computer was that you were chatting about.
That is, if you heard about this article by Nathan, I'm going to probably butcher his last name, Seidel. He's the CEO of SparkFun. He did this research deep dive into gas station credit card skimmers, and basically determined these are Bluetooth devices that respond in a very particular way and use or identify themselves in a really particular and predictable way. And he developed an app called Skimmer Scanner. He developed it for iOS and Android that will tell you, or at least indicate based on his research, if there is a credit card skimmer in a gas pump nearby. And I thought, that's great. And this is a lot of interesting research, but I'm really lazy. And what I would really like is a thing that can just sit on the dashboard of my car and just continually scan and tell me, hey, I wouldn't get my gas here if I were you. So that's what that is. That is going to be, that's in
Make Volume 63, which we just sent off to the printers and will be coming out early next month, just in time for Maker Faire.
So that will be coming along very soon, and I believe we'll be building it later this year on this very series. But that's why I was a little hesitant to get too much into that, because we'll be talking about that in great depth much later. What is next on our tour? Right, now we're going to talk about how you get this to work, and I think for this one we're going to...
That's the noobs one.
Okay, let's talk about, so there's a couple different ways to get the software onto here. And I've already pre-done it because it takes a little bit of time to create these SD cards. A couple of minutes, and don't want to wait through that dead air.
And do we call them SD cards? What do we call them when we're talking about it?
These are micro SD cards.
No, I mean when we put the OS on it.
Oh, so most of the time you burn what's called an image to these. That's not the case with the first one we're going to be talking about. It's kind of the easiest to work with, but it also takes a little bit of the most time. In fact, I'm going to go ahead and start to get this plugged in so we can start talking about it. And when we say an image, we're not talking about like a picture of a dog, although I encourage you to put pictures of dogs on your Pi. But this is an image in this terminology refers to basically taking a snapshot of the state of a hard drive. If you can imagine, you have your computer set up, like if you install an OS on your computer, it's pristine, you haven't installed any software to it yet, it hasn't gotten messed up by anything you found online or anything like that. You want to go back to that state. You would take a snapshot and create an image of that hard drive that then you could load that image back onto your hard drive and replace everything that you've done on the computer at that point and bring it back to that point. It's like a save state for your hard drive. And that's exactly what they've created. That's exactly what the Raspberry Pi Foundation does, is that they've created these images of the Raspberry Pi as it's ready to go and ready for you to start doing work on it. And you download those and you burn them to an SD card using a couple of different kinds of software. This version is a little bit different. I think these might have gotten mixed up, because this is already booting straight to the OS, unless I did this wrong.
RetroPie? Potential
Oh, I
RetroPie?
think this one, the B+,
Okay.
is, so there is another way of getting your software onto the Raspberry Pi, and it is called Noobs, Noobs. And if you've ever been called that in an online game or a social media forum or anything else like that, this is not that. Noobs actually stands for, in this case, new out-of-the-box software. So they're not trying to pick fun on you. They just have a snappy name for the software. And this is, you install this by basically, you download file or a zip file, you unpack it, you throw it on your SD card that's already formatted in like FAT32 or what you're normally used to, and then you're basically presented with an option here. It's a little bit small, hopefully you can see this, of various operating systems that you can go ahead and install. And the operating system that we would want to install here is called Raspbian. Raspbian is a fork of the Debian Linux operating system that is specifically tailored for the Raspberry Pi. Sometimes, I don't know why we're getting a very minimal setup of this here, but you can also see a bunch of different packages that you can readily install. One of them is RetroPie, which is a emulation gaming system. There's OSMC, which is sort of like a set-top box thing that lets you watch TV and other video content. A couple others in there. Some of those we'll be taking a look at later on, like RetroPie. And this is a really easy way to get started, but it's also a little bit slower, because from here you do need to download Raspbian. Yeah, actually, if we... And this is a really easy way to get started, but it's also a little bit slower, because from here you do need to download Raspbian straight into... Yeah, actually, if we... And this is a really easy way to get started, but it's also a little bit slower, because from here you do need to download Raspbian straight into... Yeah, actually, we... And this is a really easy way to get started, but it's also a little bit slower, because from here you do need to download Raspbian straight into... Yeah, actually, and this is a really easy way to get started, but it's also a little bit slower, because from here you do need to...
It should go.
Did you...
I had opened a second one. I probably put the sound to it.
Uh-oh. We apologize for the little sound thing going on. Hopefully that should go away in just a moment. And I'm getting the thumbs up. The sound problem has gone away. All right. Don't need that one anymore. In fact, we're going to take a look at some software to create a Raspbian image. And right here, we're on the Raspberry Pi homepage. This is where you can download various versions of Raspbian. You can see here there's Raspbian full with the desktop environment. You can also get the light version if you know you don't need the desktop environment. We're going to take a look at that desktop environment in just a little bit, but for the most part, we're going to be working a lot with the command line interface and talking about some of the other ways to interface with the Raspberry Pi. So this is a piece of software called Apple Pi Baker. It is a nice little front end to be able to burn images directly to your SD card. You would just select. They really carry through the Pi Bakery thing. You know, they call the image the Pi crust, And when you when you want to create a backup, they call it, extract a backup from your Raspberry Pi and save it. They call it Pi in the freezer. They get really silly with it. This is software that is available only on OS 10. That's why they call it Apple Pi Baker. If you are on a Windows machine, I commonly use a piece of software called Win32 Disk Imager. It gets the same job done. Basically, you just select your image file, where you want it to go, and then copy it over there. If you are good at Linux or Unix or other stuff, you can also use a piece of software in the terminal called DD. That's for disk duplicate. Personally, I've never gotten good at disk duplicate or DD because it scares the pants off me, because it's also a really easy way, if you write in the wrong thing, to just wipe your entire hard drive. So that's why I don't really use that very much. What I do use an awful lot is this software called, I just typed that in wrong.
Shane asked if the Pi Baker is only for the 3.
No, you can use these to burn images for any version of the Raspberry Pi. In fact, you can use it to burn any sort of image for the Raspberry Pi, including some of the stuff we were talking about, because some of the different software distributions for the Raspberry Pi, things like Octopi and RetroPie, the Raspberry Pirate Radio, which is a project we'll be taking a look at later. All of those are just images that you can burn straight to your Raspberry Pi with minimal software setup, and it just makes your project really easy to get off the ground. And you just burn those images straight, and you can use either Apple Pi Baker or Win32 Disk Imager, depending on the OS you're using, to burn those images. All it does is takes that software, puts it on a Raspberry Pi. Now, there are some considerations for the different software packages for what you're going to be, which Raspberry Pi you want to put it on. Like, I know you can run RetroPie on the 0W. You would be a little bit more limited into which games you can emulate because it doesn't have as strong of a CPU. But that's really the only consideration. The only thing that this software cares about is it has an image and a place to write it to. Hopefully that answered your question pretty clearly. But this is a really awesome, I'm going to skip this update for now, version of, this is a piece of software that lets you write Raspbian images that I recently discovered. And I like this one a lot because it lets you set up a bunch of stuff on your Raspberry Pi before you've even started. So basically you can set up stuff, it uses this sort of block-based interface. We're going to have it start on the first boot, and we want to set up our Wi-Fi network so you can create your network name and input your password, and then say we want it to be able to connect to it via SSH. So this is really good for creating what's called a headless setup, and that means that you are just going to power up your Pi. You are going to connect to it over your network. You're never going to set up a keyboard and mouse. You're just going to do everything remotely. And this is good for creating Pi-based applications that work sort of like ambient appliances in your house. Unfortunately, there's a recent update to the software on the Raspberry Pi which negate this for a little bit. And that's because it won't let you get on Wi-Fi until you have set your country Wi-Fi, your Wi-Fi region. There's different countries have different standards for Wi-Fi, and you need to tell it which one it needs to behave on before it'll start up. And unfortunately, the current version of Pi Bakery doesn't have a way to set that in the settings. I imagine that will probably be coming out in a future version of the software.
And possibly even that update that was trying to be pushed.
No, that was saying it had a version, so it automatically, if it detects there are new versions of the Raspbian images, it says, hey, there's a new version of this, do you want to download it? And that's what it was trying to do. But with that, I think it's time. Are there any other things I need to remember? No, I think we've covered all the basics on how you get your software going on the Raspberry Pi. Now let's talk about what it looks like when you actually have that going. So grab this keyboard here, or keyboard cable. start plugging stuff into the Raspberry Pi and boot it up.
We're just waiting for it to come alive.
I think I may have messed it up a little bit by powering it on before plugging in the HDMI cable. So we can't quite get to the display yet. There we go.
There we go.
There's our beautiful Raspberry Pi Rainbow boot screen.
And now one of the great things about the Raspberry Pi Raspbian community is that, like Tyler said previously, it's based on Debian. So you're able to build not only just off of the Raspberry Pi community, but also off the greater Linux community. A lot of times if you're having a problem with a specific piece of your Raspberry Pi, you can go and search without searching Raspberry Pi specifically and find other people that may have had that problem in the greater Linux community. That can be a great resource.
Yeah, I mean, for the most part, you're going to be hard-pressed to find anybody, you know, working through a lot of the same sort of projects that that it's unlikely you're going to encounter a problem that somebody else hasn't. So as long as you can identify what problem you're having and describe it into a Google search window, you will generally find yourself on some place like, what are the big programming sites? Well, you might find yourself in a GitHub thread or
On Reddit programming.
there's another one
Stack Overflow?
Stack Overflow. That's the one I keep. That's the one I was reaching for and couldn't get to.
But a
why
good
am-
tip is to copy the exact error message in quotes into Google, and usually you will come across a thread that somebody else is already asking for help on.
Why am I not seeing a display here? I was just a moment ago. Now I'm confused. That's getting a blinky red light. Maybe we get into our troubleshooting early.
Let's take a look at the message bigger.
Okay.
Oh, here we go.
That's looking better. Right? Maybe I do need to burn one of these images. Maybe we do get to do a live demonstration of that.
It went green for a second again.
Yeah, normally it should be solid. We're looking at the two little LEDs that are on the Raspberry Pi here, and normally it's a solid green, which is your power indicator, or solid red, which is your power indication, and a blinky green light. But this is getting an intermittent red, and I'm not sure what that is supposed to be indicating to me, because I've never seen it before. Well, let's go ahead and work from our noobs distribution. Yeah. There's some concern over the black screen from Matthew, who's helping us out here in the studio. I'm like, no, well, it's not supposed to look like that, but it is looking like that at the moment. Anyhow, we're going to get back into our noobs distribution. This might take a little bit while we get Raspbian set up, although Raspbian is already stored locally on here, so hopefully this won't take too long. And if you have any questions, this would be a really awesome time to ask them, because it looks like we're going to be here for a little bit while we get this installed.
Zen Beeblebrox says that he thinks that that blinking light pattern means an issue with the SD card or image.
That might be a little bit surprising. I mean, I'd take your word for it, because that's, I did just burn this, and I didn't do any verification or booting, but we did just see it boot just a moment ago. Although they always tell me that you're not supposed to just unplug the cable on it. I always do. I've never had any trouble from that. But maybe we just encountered a problem with it. In the meantime, while we're waiting for this to get installed, I guess it's a good time to jump ahead a little bit and talk about some of the Raspberry Pi accessories that are out there. It's a good time to get the camera out again. Somewhere here, I had the Raspberry Pi camera. Get this out of the way so we can. Oop. That was not what I had intended. Apologies for that. Didn't realize that this camera had come unplugged.
HDMI cables everywhere here.
We don't want that, we want this. All right, so this is the Raspberry Pi camera. It's not very large, as you can see here, so it's good for really, really tiny applications. It uses, the ribbon cable isn't normally this long. This is an extra long one. I believe this is one of the ones we used when we were building the PiCon telescope for Make Live last year. Normally, they're just a few inches long, just long enough for you to get the camera a little bit further away from the Pi, just in a position where you'd want. There's a bunch of different applications for these. People have made all kinds of cool things like, well, last year we built the Raspberry Pi GIF camera, the Pixie GIF camera. People use these a lot when they're building Octopi setups, so you can use these to monitor their 3D prints and take time lapses of them. What are some of the other cool Pi camera projects?
People do pet monitoring camera projects. They use it for robotics.
Yeah, we also used one, not exactly this camera, but a wide-angle version of it. If you caught when we built the Raspberry Pi RoboCar at SparkFun AVC last year, we used a camera, and that was its only sensory input to the world. It uses that to build a model, use that to see the world and build a driving model, and then use that to figure out where to go. All right, so there's that. This is, I guess we could power this on. No, we can't, because we only have one power cable. This is tricky to get this all into the frame here. So we have our zoom macro or prime macro lens, but this is the Raspberry Pi touchscreen. I've got this all in an enclosure here. If you saw my video about running Universal G-Code Center on a Raspberry Pi, this is my CNC controller at home. Well, it's not at home anymore. But yeah, it uses the Raspberry Pi touchscreen. I'm using it predominantly for a display. I use an external keyboard and mouse. But this is like a 7-inch touchscreen display. I think the resolution for it is like 1024 by 860 or something like that. I'm probably getting that number a little bit wrong. But it's decently high resolution display. And yeah, so we lets you, and if you want, you could even build this into kind of cool like tablet display or in-car dash computer, or all kinds of cool stuff. So that's just a few of the accessories for the Raspberry Pi. There's a bunch of other stuff you can get for it. A company called Pimeroni makes a bunch of add-on boards that you can add. I just saw a really cool project recently that uses both the Pi camera and this Pimeroni, what they call the speaker hat, that attaches to the GPIO pins. And it creates a device that lets you you push a button and it connects to a neural network, and it uses the camera to take a picture and then uses a neural network to determine what that is that you've just taken a picture of, and then identifies it and says it on the speaker. And if I have time, I'm hoping I can build a badge version of that for Maker Faire. Yeah, it will probably be a big badge, but it'll be fun. All right, let's take a look at how our Raspbian install is doing. 37%, that's not too bad.
And some of the chat on YouTube have speculated that they saw an underpowered voltage message briefly on the first boot up when we were trying to boot it up. And also somebody said that sometimes yanking the plug can cause disk image corruption. Somebody who teaches in the class Urban at Work with teenagers who often do that.
Yeah. I guess I'm a teenager because I also often do that. But and most of the time I haven't had too much trouble with it. But there's always an exception to every rule, and it's always a good practice to actually shut down your Pi properly. We'll get into that once we start getting into the software. And it's good to see that at least during this live demonstration, I was able to demonstrate what not to do. I am curious about the mention of the low voltage message, because hopefully you guys can see it on the stream here. There's this little lightning bolt. I'm hoping you guys can tell me this, because I've never really been too sure. There's this little lightning bolt in the upper right-hand corner of the screen. Does that mean the low voltage warning? I would be curious to know.
I think that it was there was a error message on the previous one when we were watching it scroll trying to boot up.
Yeah.
The one that was throwing the link error.
And this is, of course, still using the same power supply that may have generated that low voltage warning. So if that's the case, then we should probably find a different power supply to use.
The lightning bolt means low power, says Jesse McCormick Jr.
Interesting.
What is our output power cable?
It's doing 5 volt, 2.1 amps, so it should be. Well, it is a little bit underpowered for this this Pi 3B plus. It has the right voltage, but it's down a little bit on amps. Interesting to know, because I feel like I've seen that on just about every Raspberry Pi I've ever used.
I know that there's different voltage requirements among the different versions, right?
Yeah. Well,
yes.
but they're all USB, which is all. I mean, who knows with the various USB power supplies if they're actually delivering 5 volts, but that's what the spec should be.
Right.
Because that's just USB.
It might be the cable, maybe? The cable is a micro USB, not rated for real power, but rated for that down throttled.
It is. This is also a pretty long cable, so I wonder if that is the cause.
Yeah, we are running it around the ground a bit.
But I do have a backup plan, and I can do that if I just unplug my microphone for just a moment. So I'll be right back.
And our install is hovering around 60% now. Looking good. And you can see that it's giving you all kinds of useful tips and help to get you started, directing you to the forums and downloads and resources. And the Raspberry Pi community is pretty great. You can either go directly to the Raspberry Pi Foundation, or you can look. There are several places online, forums, and different hangouts where people exchange tips, different builds, project ideas.
All right, so apologies for unplugging and plugging the mic back in. Hopefully that didn't produce any rude audio noises. The other nice thing about the Raspberry Pi being powered entirely on USB is that you can also power it and make it a little bit more portable by using one of these USB battery bricks. And so we're going to be using that for the rest of the time here, just so that we can use that to get the Pi powered. Hopefully we don't see that low voltage warning anymore, and have a better time with it and not corrupt any more SD cards. So I'm eager to get into the software stuff here and show off some of the other cool things you can do with the Pi other than stare at it as these progress bars slowly climb up. I think I saw that somebody also mentioned photo booths. Again, we're kind of going through the tour of past Make Live projects. We also built the Raspberry Pi photo booth, which used not only the camera but the touch screen that we were just taking a look at.
And I don't want to give anything away too much, but if you like photo booths, you should check out the next issue. Just saying. Just saying.
I don't think I even saw that project.
It's amazing.
Cool. Now I want you to give more of it away.
Several people on YouTube are also confirming that long cables will give a larger voltage drop.
Yeah, that makes sense. Fortunately, with this battery pack that we have here, we only have this very tiny cable, so I think we shouldn't be too worried about that. Yeah, I do know that at least as far as, because I occasionally have some really long USB cables that I use expressly for powering things that are less demanding of power than a Raspberry Pi, like various Arduino things, and sometimes those are like 15-foot cables, and I know that you know, the USB cable at that point might be good for power, but I wouldn't expect the data pins to be doing much good or be very reliable there. I've heard of some people in the 3D printing community, they don't want their printer particularly near their computer if they're printing directly from their computer to their 3D printer. So they run it over a pretty long cable and sometimes have troubles there. You can mitigate that somewhat with if you put a powered USB hub in the middle, that helps boost the signal again a little bit. All right. Come on, noobs.
We're getting close. It's a race.
Yeah.
Anna asked if the new photo booth project could be used at a wedding. So our old photo project that we built on Make Live, I believe, was actually made originally to be a photo booth at a wedding or at parties.
I think it was. And granted, the one that we built was the kind of easy kit built one that was just, you know, here's some 3D printed parts. It didn't look very elegant. The one that they built, I think they made it look like the Instagram camera. Yeah,
it was all clear and beautiful, right?
Yeah. And otherwise, and then the one that we built for the magazine, I say we, but the interns that we had at the time, that was Jenny who built that?
Yes, and she gets so much credit because it was so extra. Really, really well done.
I mean, it looked like a beautiful, oversized, it was like 3 feet wide rendition of a classic Canon AE1.
Yeah, and it was spot on. She laser cut vinyl cut the lettering so that it really read like a old Canon.
Yeah, really beautiful job with that one.
So I recommend looking up that old episode of Make Live for Anna and checking out that build because it was super fun and people really love them at parties.
Yeah. I think we were getting dangerously close, 90%. And yeah, we are very nearly there.
So people are asking about the new addition to the background, which is the pixel frame up here.
Yes.
And this is a great time to talk about that.
So that is, if you are a fan of Tested or listen to their podcast, you may have heard of a project by the regular host on their podcast, Jeremy Williams. That is called the Game Frame. And what it is it's a 16 by 16 pixel grid. Each one of those individual pixels is, where is?
We have a second one that we could show you, but we seem to have misplaced it.
I probably hid it somewhere. It's behind no, it's not behind there. And each one of those pixels is powered by a NeoPixel, if you're familiar with those from Adafruit. And it's powered by a Teensy, and you can put in your own, the SD card that you get with it comes preloaded with all the animations that you see up there, but you can also create your own animations. You can design them.
And Matthew has been kind enough to bring us the other one.
Yeah, this is what it looks like. Each one of these squares you see here makes up an individual pixel, and you can buy it now. Can you buy it now in Makershed.com?
Yes, now on Makershed.com.
Yeah, it originally started as a Kickstarter and a kit that you kind of had to assemble yourself. Now it comes completely pre-assembled. I'm not going to bother taking out the back here, but you can see the TNC there, the input for the power, and it's a fun little thing. And there's also a little IR reader here with a remote control.
So that you can fast forward the animations and turn it on and off.
Yeah.
Adjust the brightness.
There's the little remote. You can turn it on and off. There's a clock. You can have a display. There's all kinds of cool stuff you can do. It is a fun little project.
People keep saying something about a chicken, and I don't know what they're talking about. Weird.
I don't know why we'd have a chicken in this studio.
Yeah, there are animal laws in San Francisco.
It says 100%.
Yay!
But it's not really 100%.
No.
It's the optimistic 100%. We're nearly there. Now it's extracting the file system. I would have thought you would have done that already.
And Urban at Work went and hunted down what exactly that icon is. And they say, on the subject of icons, now been replaced with symbols that make it a bit more obvious what's actually happening. There's a lightning bolt for under voltage and a thermometer for over temperature.
Okay, that's good to know. I should check on some of the Raspberry Pis that I have set up around my house and maybe address their power needs better than I have been, now knowing that that's what that means.
And I will say that one of the common problems with Raspberry Pi boot issues is unclean power. So if you're having boot issues like us, the first thing to check would be power, and the next thing to check would be your disk image.
Yeah. In this case, we did both. And I think it is done. We're going to click this OK button and go through our standard boot cycle, I hope. Yep.
Yay! You see the telltale scrolling of all its package checks.
And now, oh wait, no, that's the thing I haven't done yet, is actually switch over to the real power supply yet. So I'm going to do that in just a moment. Take a quick look here at the Raspberry Pi desktop environment before we shut down and get it some good, reliable power.
Goodbye, friend.
So thanks for sticking with us through that short delay of a live installation of the operating system. I'm going to wait for the activity light to go away. Enough with you, bad power cable. And hopefully we won't be seeing that lightning bolt anymore.
I love the rainbow gradient startup screen. No, the lightning bolt is still there.
All right, now I just don't trust anything anymore. All right. Well, we're going to carry on. We're not too, because that's the other nice thing about the Raspberry Pi is because it's cheap, because you can easily reinstall the software as quickly. You don't really have to worry about breaking anything. I don't know if you ever wanted to learn a program on, if you were young and wanted to use the family computer to that, and somebody was like, "Oh, I don't want you to mess anything up." And messing this up is going to be really not problematic at all. Even if you do something to damage the hardware, you're only out $35 in the time it takes to order another one.
And if it's the Pi Zero, you're only out $10.
If you mess up the software like we already did, you're only out a couple of minutes, which is painfully slow in a live stream, but in the time that it took to get the software reinstalled, you just get a cup of coffee or go take a break or pet your cat.
Take a nice walk.
Take a nice walk or do anything that you need to relax and think about the horrible thing that you just did to your cheap computer. Because it's actually that horrible. Anyhow.
And the other cool thing I want to mention just real quick is that, so this is a very unintimidating real computer, and I like to get people started on Linux, but if you set up a whole computer for them, it can be a little intimidating. When I hand this to somebody and I hook it in with a keyboard and a mouse and their monitor, it's super fast. They don't feel so scared of jumping right in and figuring out this weird operating system that they may not have used before. It's way less intimidating.
Yeah. Anyhow, so let's jump back to, so this is the desktop environment, and it looks like any sort of desktop environment that you might use on a computer. Some of the icons are in different places. Like here, the thing you use to, almost like the Windows Start key is in the upper left instead of the lower left. You see a couple different things here. We get go here, and we've got a web browser. It's not the most high-powered web browser in the world. In the meantime, there's a clock here. We'll get into the clock currently says it is 11:20 p.m. And that's because by default, also the clock is just straight up wrong on here. But by default, the Raspberry Pi is developed. The Raspberry Pi Foundation is based in the UK. And you definitely see it when you come across the defaults. The default keyboard layout is for a UK keyboard. The default time zone is in GMT. So there's a couple little trappings all through there. We're very proud of where they're from. Let's see if we can do the we aren't connected to the internet. Of course not. We can't go to YouTube.
Do we want to show them via ifconfig, or do we want to show them via the GUI?
Well, at the very moment, it's telling me that the first thing we need to do is
that country localization we were talking about.
So it's a good time to, well, let's go back to, exit the Windows interface here. See if I can remember how to do that. I spend almost zero time in the desktop environment.
Yeah.
Can I do that from shutdown? No.
We could just spawn a terminal, though.
We could. I just want to make sure it's going to be large enough, sorry for coughing,
Oh,
for
that's
everybody
right.
to see. There's got to be a preference here to make the text super big.
Bear with us. We're setting it up so that you guys can read. Sorry, you all, so that you all can read.
Everybody can read. Okay. Now that's
Much better.
much sizable, and we're going to get into a really important command to use when you first start setting up a Pi, which is called rasppi-config. This is when we're going to start talking about some Linuxy stuff. If you notice, I also typed in this thing called, before rasppi-config, I said sudo. I think that's generally accepted. That's how it's pronounced.
Sudo.
And that means super user do, which means that the default Pi account on your computer basically acts as the super user admin of the machine. It has most of the privileges, but there's a couple left over for what's called the super user or root. And that's the user account that can do anything on the computer, including completely ruin everything.
And it's generally not good practice to directly be root, but sometimes you need to do things as root in a way because you need that level of permissions to execute it.
Right. In this case, we want to use that level of permissions to use rasppi-config. And so sudo here says I wanted to run it as that user, so we have all the configuration capabilities available. Some of the first things we want to do is go in. Actually, the first thing we want to do, and the first thing you should always do with any Raspberry Pi project, is change the default user password. The default password, when you set it up, is the user is called Pi, the password is Raspberry, and now you know that. Everybody who's ever used a Raspberry Pi knows that. So if you have your Raspberry Pi connected to a network, that means anybody who's ever knows anything about a Raspberry Pi knows how to log into your system and wield an awful lot of power over your system, which can do things to exploit other things on your network. They can certainly ruin your Raspberry Pi.
Get information about you that may be stored on it or things that it has access to.
Yeah. So this is the easiest and cheapest form of security that you can do. And then, yeah, you just create a new password for yourself so that at least it's something that nobody else is going to automatically know.
And the reason that you want to sudo things instead of running as root, again, is that protects you when you're out, in case you forgot what account you were in later, when you're still messing around in the terminal, you don't accidentally rm-rf your entire computer system because you forgot that you were running as root.
Yeah. All right. Next thing we want to do is get our Wi-Fi set up. We go into a Wi-Fi here. You can also do cool stuff like set up what your Raspberry Pi will look like on other computers on your network. Typically, it's just called Raspberry, I believe, or maybe Raspberry Pi. Here, we're going to ask us to enter our SSID. Here, it's just called make.
We should probably switch screens for just a moment while we type in our Wi-Fi password here so you don't all cruise by our building and get on our network.
I had to do that one from muscle memory because and when this must be an older version of Raspberry config. Oh, yeah. Here we're getting into setting up the host name. We're going to leave it as Raspberry Pi. Sometimes you will see, or maybe it is still the localization options. Change your Wi-Fi country to...
Oh, we're all the way at the bottom.
Yep. It is alphabetical. We're in the United States. So you go all the way down here. Although, to be fair, we're right down here with... actually, no. They don't have the UK here.
I think they get to be at the top. When you write the software, you get to put your country first.
Yeah. Again, other localization. Let's set our time zone. We're in the U.S. We're in...
Where are we?
Pacific New. I don't know why there's a new Pacific one. Interfacing options is a good one to get into here. This is where we can enable SSH. SSH is a way of, it stands for Secure Shell. It is a way to remotely, through a text interface, connect to this Raspberry Pi and do admin stuff on it, or do anything on it. And we want to enable that.
And that's critical for running headless, which we talked about before, which is where you do not connect a monitor or a keyboard or a mouse, but you still want to access your Raspberry Pi. You would do it over SSH.
Yeah, the other thing that we can do over for headless installs is set up what's called VNC, and that is a remote, it's basically a remote desktop environment. So you can also enable that. I don't know if I have any VNC software installed yet on my Mac, so maybe we won't show that off today. A couple other cool interfacing things. There's SPI and I2C. These are two different interfaces that you can use over the, in fact, I believe all these SPI, I2C, serial, one-wire, remote GPIO are all different things that you can use. They're basically different interfacing options you can enable through the GPIO pins. We won't be playing around with any of those today, so we'll leave those alone. No, I don't want to do that. There's the update stuff here. We're going to be doing the manual version of that in a little bit, so we're just going to say finish here. We do need to reboot because we made some system level changes here. So we'll step away here and come back to us while we wait for it to reboot. What other stuff to talk about? Oh, the other thing that you can set up in Raspberry config, and I might jump back in there in a moment, although actually I think the display there is you can also set up your Raspberry Pi so that it boots straight to a command line interface instead of going all the way into the desktop environment like we were just seeing. So if you don't need to deal with the desktop environment, you don't want to deal with the CPU overhead that brings with it, you don't need to deal with it. As I mentioned, there's also the Raspbian Lite distribution, and that just doesn't have the software involved at all.
Do we want to talk about auto-starting programs right when it boots?
I think that's a good topic to get into a little bit later. There's a couple different ways to do that, and that's good for creating, if you have a project that you want to do and you want it to run as, I always refer to as running as an appliance, because everything that runs on the Raspberry Pi is essentially software. But if you want it to, even if it's software that does a specific function, like we were talking about the GIF camera, normally you would, that's all runs as a Python script, but you would need to boot the Pi, log into it, launch that software. So this is different ways you can have that software run automatically so that when you power the camera on, it just goes straight to being a camera, which is kind of what you want it to do. Anyhow, we are back here at the desktop environment, and pull up a terminal window, and another important command to get into, we're just talking about updating the Pi, is we're going to do this sudo again. and we're going to do apt-get, and the first one we do is update. And we're going to do this one. There's 2 steps to making sure that the software in your Raspberry Pi is completely up to date. The first one is update, and this one goes really quickly because all this is doing is grabbing all of the lists of packages that have updates on your Raspberry Pi software. So this just says, okay, let's look at everything else out there on the network or on the internet and says, oh, we have updates for all these different packages we already have installed. But it goes relatively quickly. Actually, this is going a little bit slowly. Our Wi-Fi must be a little bit slow today. Oh, okay, now it's done. The next step you would want to do, and we're not going to do it here because it can take up to like 45 minutes, is upgrade. And this is where it takes all the lists of updated software that it just downloaded and says, okay, now we need to go and download and install that software. So we're not going to do that one. The other thing worth talking about is the environment that we're in right now in this terminal window. Actually, I'm going to ask, can you guys, I'm wondering if it's a little bit dim. I'm going to go back into preferences here and see if I can brighten up the display. Although it's...
I think that might be a hardware thing because through the screen it looks great.
Okay. Yeah, this monitor we're looking at, although it does have this foreground color that looks like we could brighten up a little bit, so we'll see how that looks. That's a little bit brighter. I just want to make sure, because we're going to be getting into some specific commands here, but this is referred to as a command line interface. And if you haven't been working with computers since the 80s, you might not have ever seen something like this before. But this is basically just a text and keyboard way of looking at the guts of your computer. I'm here in the home directory for the Pi account. I can see what's in here with the account ls, and it has a lot of the same stuff that, you know, if you look in the home folder on your Windows or Mac computer, you see a lot of the similar sort of stuff. You see a desktop folder, a downloads folder, and a bunch of the other same sort of things you would find in a modern desktop environment. You can change directories. You can go down one directory level by doing this. CD is change directory. So now we're just here in the home folder. If we had a lot of other users on here, we would see somebody else other than Pi. We go down one more, and we're in the root folder. And see you will find these folders in just about any Linux or even Unix operating system. You recently found a cool, you found a cool cheat sheet on like what these different folders and things all represent on
I did.
On a Unix operating system.
And we actually have that here. I don't have it a virtual version, but we can talk about some of the things that you see on the screen now. You've got bin, which is where your programs and commands that all users can run live. And you've got your boot directory, which is where all your files live at boot time, which we're going to talk about later. You've got dev, which are all of your device files. And et cetera is where your config files live, which earlier when we were touching the config files, that was the interface to that directory. And then you've got a bunch of other things like your lost and found, your media, which is where your removable media lives, not where your photos and songs and media files live. This is where you would have your mounted drives and your other things like that, peripherals, etc. You've got your home directory down low. Then you have your lib, which is where the kernel modules and drivers are. And the other systems here are for like your log files are in var. You've got your temp directory for all your storage files for the things that the system's doing, your user files, etc.
Yeah.
And you can learn a lot more about this in our Getting Started with Raspberry Pi book, where they really detail out a lot of what each of these directories are for.
Yeah. I'm going to take one of the other cool ones in here is dev. That stands for devices. And if we this is basically just the hardware interface for every single thing that it considers a hardware device on this computer. You mentioned mounting drives. When if you were to plug in a USB stick or something like that into this and wanted to access that, you would need to what's called mounting that device first. You would mount it to that media folder, but first you need to figure out where it is. And so you can do like ls. Ls is, I don't know what, ls probably stands for something, but list, okay. And those are generally SD. They're probably not populating here because they don't have anything plugged in.
Yeah. And we've never plugged anything in.
But you've got like all these TTY devices, and the other cool thing that helps you navigate around is tab completions. So I just type T, and then I can press the tab key, and immediately it jumps ahead to autofilling TTY. And then we have all these numbers. You can go, how many? And that lists all the ones that are under TTY3. It's a super useful tool that helps you navigate around the system and also make sure you're not misspelling things or mistyping things.
Yeah, I've integrated tab completion to make sure that I'm typing the correct thing, because you can do critical errors. Like you can see these TTY files are all the similar numbers. So if you mark the wrong thing, sometimes it can be detrimental to what you're trying to do with your system.
Yeah. Tab completions have come to, if you ever play around with the command prompt in Windows 10, or also the terminal in OS 10, you have tab completions there. And in fact, if you ever play a fun little game on Steam called Hacknet, eventually they're even to put tab completions into that game, which is a thing that made me very, very happy. Tab completions are great. They make you feel like, well, they let you type a lot faster and let you type a lot smarter. If you want to search in a big, search for a specific thing in here, say we want to look for all these VCS things, we want to get a short list of that. Another thing you can do is ls and then pipe it into that's not a pipe. Oh, because I haven't set up my keyboard layout. I'm still in UK land.
So if you remember earlier when we were setting up our regional preferences, one of the things we mentioned was keyboard layout. And that's because in the UK, they have different buttons in different places.
Yeah, they have some weird symbol that represents currency that's not the dollar sign.
Who even knows what that is? It's a curly thing.
Yeah. You can set this up as a 104 key. I have to go all the way to other layouts, not the UK layouts. All the way up to the top for just standard English US keyboard. And I always just accept the defaults here. I don't really need to do that. And then it takes a short moment to reload the key map. Hopefully don't need to rebuild. So ls, and then you do this. So ls is what lists all the contents in a directory. Then we can use the pipe symbol. And that says, instead of going to display, I want it to go to this next program I'm going to type in. I'm going to type in this program called grep. Grep is basically a search thing, and we're going to look for all the VCS.
And so pipe literally acts like a pipe. It acts like a connector that the data flows through into this next program.
So now we see here, it has returned all the things that started with the VCS, and it even highlighted the part that we were searching for. So that's a cool way that you can just easily search for stuff while navigating around the ls. You can make it recursive, so you can have it start at the root folder, search the entire contents of this computer for all. If you have a file and you forgot where it was located, in this case, let's look for a key file that we might get into later called rc.local. So that's ls-r. All Linux commands have a ton of different flags that make them behave in different ways.
You can memorize them if you are a good person, but some of us are not good people, and they make a lot of cheat sheets, and you can also always read the man page, which will tell you what all of those flags mean.
Oops. I must, does rc.local exist until you set it up?
I don't actually know.
Okay, well, we'll forget about that for now. But yeah, what this should have done is, if we just run it without grep. The other cool thing about tab completions is that if you type the up arrow, it'll automatically go back through your command history and let you page through that. So if you want I must be mistyping. Is it -R? Yep. That's why we didn't find RC local.
And that's another good lesson, which is that capital letters and lowercase letters mean different things in those flags.
Yeah.
And you can see we look like really cool hackers right now.
Yeah. We've just downloaded the entire matrix.
If you are ever working on a TV show and you want to look like a hacker, you can do ls-la and it will make the screen flood.
Or you could just go to hackertyper.com. But yeah, this is a good way of just like, we need cool computer stuff, serious computer stuff going on. So if you do, and then pipe it into grep for rc.local, I bet now, I probably should have run that as sudo because I was trying to get information on lots of things that the Pi account shouldn't be looked into. But here we see it returning a lot of different stuff for RC local. In the meantime, what are some of the other things we need to take a look at here? Well, there's text editing, and this is where, so a big part of why people use the Raspberry Pi, and a lot of the original intention for the Raspberry Pi, and why it was designed, is they wanted to create a computer that people could learn to program on that was cheap, and so that people who didn't have the opportunity to use a regular computer or a fancy computer like a MacBook Pro or even a modern laptop, they just don't, for whatever reason, they don't have access to tools like that. They definitely can, or they more than likely can get access to a $35 computer, and they can use that to learn to develop software. And there's a lot of stuff that's already built into the Raspberry Pi to begin learning programming. There's a block-based visual programming language called Scratch. You're already ready to start developing in Python. And anything that's not on there, you can easily download using the apt-get. Same software we were using to update it. You can also use it to download software. And the great thing about apt-get is that not only does it get the software you asked for, it also gets all the software that software needs to run. The open source community is very much dependent on, it uses what's called dependencies, and software is built on other pieces of software built on other pieces of software. And when you say, I want to get Python, it says, oh, okay, you need Python. Python needs this, this, and this. We're going to get all of this stuff and download it for you so that it's ready for you the next time you want to actually use it. And that's one of the things that, as Linux has grown over the years, is one of the things that's done to just become a lot more user-friendly. Anyhow, one of the things you'll be doing when you are writing software is editing text files. And the one that I use all the time, because I don't know how to fly a space shuttle, is Nano. And this is just a text file. I'm going to do some quick typing, and then do Control X and save it. And now if I do an ls, I see that we have this hello text. There is another piece of software that people like a lot called, are we nearly running out of power and not charging? Mm-hmm. That's not good. This is on the streaming computer, not on the Raspberry Pi. Why aren't you charging?
I just swapped the two. That one's not plugged in anymore.
Okay.
That's charged a tiny bit now, because it was at 7% before.
Let's keep a close eye on that. Hopefully we don't have to wrap this up early. But yeah, it's 8%. It was at 7. It's got the light. Maybe Windows is just being weird. I hope not. Okay, well, we're moving right along pretty well. And we've already, that's pretty much a lot of the basics about the command line stuff. So we can go out of that. We talked a little bit about working headless. So let's, here's an important thing that you'll need to know when working headless.
Plugged in and charging again.
Yay! We don't have to wrap up early. Although we are moving along pretty well. This is another important one to learn, which is ifconfig. And this will just give you a quick glance at your network stuff. And in this case, I wanted to get the IP address that this Raspberry Pi is currently living on. And I see it's, thanks to our network router, it's been given this non-routable IP address of 10.2.1.165. So we are going to jump from here over to, I'm going to go back over to my MacBook here, and that's the MacBook. And I'm going to open up I need to move my keyboard so I can actually type on the MacBook because it's far away from me. All right, so we've got our terminal window here. I need to increase the font size on here as well. Where do I do that here?
There
Change.
you go. And we'll get it bigger so you guys can see exactly what we're typing.
24. Oh, that should be good. That's a little better. I think we can go bigger. I can go a little bit bigger. Well, let's just, how's it look on there, other than dark?
It looks good.
Okay. So from here we're going to, here's that command again, SSH, not SHH. And then we do pi at, what do we say, 10.2.1.165?
Yes.
And the first thing it'll say from the message here is that it wants to verify, like, hey, here's the key fingerprint, that RSA key fingerprint that the computer identifies as. This is important because if another computer uses the same IP address, the macOS will remember that and say, I think this is not the computer that you think it is. It maintains a file of IP addresses and these key fingerprints. But we're going to say, yep, that looks pretty good.
And just a tip, if you're ever at a security conference, do not blindly accept a new key.
No. We typed in our password that we changed into earlier, and now we're back in the same environment that we were in before, but now we are looking at it from a separate computer. And we can do everything that we could do before. And this is, if we wanted to get access to the desktop environment, we would use that VNC software. But I don't have a client for that set up right now. But just to remind people, I am still on my MacBook. You can see here I still have my, you can see I have my Spotlight search. We're still on the internet. Or I'm still on my computer, but I'm remotely connecting directly to this Raspberry Pi. What other topics did we have to cover? And if you are not on a MacBook or on a Macintosh computer, you have a couple different software options for using SSH. On Windows, there's a great piece of software that I've used for years called PuTTY. I also understand that I don't know if it's in full releases of Windows 10 or in beta releases, but there's like a full bash shell available for Windows now that has things like SSH built in. I haven't played around with that stuff yet, just because I've been a little bit lazy with checking some of that stuff out. And also because I just use PuTTY because it works. What are some of the other things to cover? We talk about the accessories. So I think now it's time to get into some of the favorite projects that we have worked with over the years, and some of the things we encourage people to definitely check out. There's a lot of really cool stuff you can do with this thing. First of which, I think we should, this is one of the first Raspberry Pi projects I ever encountered. This is the Raspberry Pirate Radio. Hardware-wise, couldn't be simpler to build because this is just a piece of fairly heavy gauge solid core wire that's just plugged into one of these GPIO pins. You can see there. And we're going to power this on. And, we were talking about safely shutting down your Pi. So let's safely shut down this Pi that we've been working with here.
I wanted to check the YouTube.
Oh, is YouTube being weird? Well, I mean, we're still getting, or is anybody saying dead air?
Can you see us on YouTube right now, guys? Let us know if we are still streaming to the YouTube channel. Hey, Matthew.
All
right, we're good.
All right. Still getting the good thumbs up. Thought things were being wonky for us there. But we talked about being able to safely
shut down and unplug.
Shut down a Pi, and that is, we're going to, again, do this as the super user. So sudo shutdown, and we're also going to say now, because you can do a couple different things with shutdown. You can say, do it in after a certain amount of time. You can have it shut down at a specific time. Also, whenever you are curious about all the different options a piece of software in Linux has, you can say down, and usually it's a -H, or you can do --help, and it'll give you all the different options that you can send it. In this case, we can also say sudo reboot if we want to force a reboot and have it come back up, but we don't want to do that. We want it to power it down. So and now we're back to our computer. The Raspberry Pi is shutting down. We can see when the activity light is done blinking, we now it's powered off, which it has just done. But one of the first things it does is it closes network connections, which kicks us out of SSH. If we'd been directly connected to the Pi, we would have seen the full shutdown sequence. But in the meantime, we have some fun radio to listen to. So this project, come back to this camera here. This project, somebody realized at some point that if you, by oscillating one of these GPIO pins on the Raspberry Pi, it would actually work as a radio transmitter. And it would actually broadcast on normal radio frequencies.
And this is one of the easiest Pi projects to do, both software-wise and hardware-wise. But it still manages to impress your friends and look really cool, and you totally look like a hardware hacker, even though the investment in it is very simple.
Yeah, and again, we're going to continue the tour of old Make Live projects. You might remember this one, which is the Diesel Punk cell phone that we built live. And one of the features that we never really...
Swap cameras, though.
Oh, you're right.
So that you guys can see with us.
One of the features we didn't really do for that live build is that there's actually an FM radio tuner on this. It's the Feather Phona board. I never set up a radio antenna on here. There's a place to solder a wire onto there to act as an antenna. So I'm going to actually need to get, this is a bad radio receiver. It's a good cell phone receiver. It's a bad radio receiver. So I'm going to have to get it really close to the antenna to hear the music that we are broadcasting. But this actually will broadcast pretty far. In fact, I'm concerned that people are hearing music on the street outside our office. So we won't be having this running for that long. But in the meantime, hit the 3 key, and this is broadcasting on 96.5.
And I'm going to take my microphone off so you can hear. And if you can hear, our radio station is playing a very familiar song.
Yeah. I think we should probably stop doing this because we're past the 6 seconds that you're allowed to do this. Hopefully that doesn't get us content ID'd. But anyhow, I hope you enjoyed that. So that's a Raspberry Pirate Radio. You can make this nice and portable, so you can have your music broadcast to your local friends. You can do all kinds of cool stuff with this, like what do they call it? The silent dance party kind of thing.
Right, silent disco.
Silent discos. You just do all kinds of fun stuff.
And so you should check the legality around your broadcasting laws, but a lot of times underpowered transmitters are okay. I think if they're under 1 watt.
Yeah, because this is basically functions the same as, well, it's like a higher powered version of the same sort of thing that, if you had something that if you have a car stereo that didn't have a CD player or something like that.
Or an aux in, and you want to play with your iPod, so you would get one of those little radio dongles that you plug into your cigarette lighter. This is about the same level.
Yeah. There's fun stuff you can do with that. There's a neat fork of this project that lets you run your own gimmicky number station, which I need to build one of those at some point because that's fun and hilarious. The next one we're going to talk about is RetroPie, which I believe is on this Raspberry Pi. And RetroPie is just, turn the radio stuff off here. Oh,
and remember, again, with radio, it's also country by country. We talk about the FCC here in America, but in many other countries, they have more permissive or more restrictive radio laws. So you should check with your local area. Good
call, yeah. I mean, if you're in an area with much less radio restrictions and you want to play some cool tunes for your neighborhood, this is the project for you. But if you don't want to play cool tunes, but you want to play cool video games, RetroPie is a distribution of Raspberry Pi. It's really easy to use because it's basically distributed as an image that's ready to go, and it has a number of different video game emulators already built into it. You have to come up with your own software. There's some questionable legality around that, especially here in the US where we have the application of the DMCA, where it's sometimes legal to get images called ROMs of your old game hardware and run them on this. Sometimes that's legal, sometimes it's not. Usually it's legal to own them, but not legal to create them. And those laws are super weird. But in the meantime, let's get this going so you can see what the interface looks like.
An SB Farmer 8 corrected me. It's less than a milliwatt, not less than a watt.
Because a watt would actually be a pretty powerful transmitter.
I think a watt is 1 mile, right? I can't remember my old radio hacking days. Not that I ever did anything.
And give this a little moment to, actually it's already starting to boot up.
We've got this speedy boot, and we see the cute little RetroPie logo, which is one of my favorite logos.
Yeah, a little splash screen while it continues loading, and unfortunately I saw an error earlier, or not an error, but a little bit of a glitch where I wasn't getting audio from this. So we're not going to spend a ton of time in here. I only loaded one game on here. It's pretty much the only game you need, if I'm honest. And that's why I need to move my keyboard over to the Raspberry Pi. But it will populate, depending on which ROMs you have installed, it'll automatically detect them and pull up menus for only the emulators that you have ROMs installed for. So that way it keeps this nice little interface uncluttered. I'm going to jump into here. And it just takes a little moment to load in.
And here we are.
Oh, that's right. P was my start key that I encountered. Unfortunately, I left my my little USB SNES controller at home today, so I'm just going to be playing this with a keyboard. Yeah, it doesn't look like we're getting audio from the game. I apologize. Just paging through this text here. I know, it's almost like we're streaming on Twitch.
So Michael Colley on the YouTube channel just asked that when he tries to boot his new Raspberry Pi 3B, it gets stuck at the multicolor screen and has a lightning symbol in the top right corner.
This sounds a little bit like some of the issues we were dealing with earlier. The first thing I would check is, and actually I can show this in a moment now that we're not.
I actually have a exact graphic perfect for this situation to let you know, and I'm going to drop the URL into the YouTube live stream. And if Matthew could kindly cross-port it to
Oops, I died.
Facebook.
Well, that's probably enough of buying a commando. I mean, honestly, I could keep playing this game all day, and that's not really something I should be doing now that we're getting close to the end of our live stream. But I'll see how easy this is to see here on our tabletop camera, because even though we can get really close up with this lens, this text is very small. Let's see if we can get it.
So small.
But you see here, it says the output, it says output DC 5 volts, 2.1 amps, 2.1A. These USB chargers, they all have a USB port, and because it's USB, it'll all be 5 volts, but they all output at different amperages. And sometimes you'll see them at like 0.5 amps. A lot of very cheap cell phone chargers will be like that. If you're, they come 1 amp, 1.5 amp, 2, and they're starting to get more and more and more as cell phones get more power hungry. And that's why these things become really ubiquitous. And if you have a phone that tells you whether your phone is charging rapidly or not, that's generally dependent on the amperage. If your phone can accept a large amperage to charge quickly, it will then charge much faster if you have more amps. And if you don't, if you're just drawing on like 500 amps or 500 milliamps, I should say, it will be charging more slowly. In this case, I would look to this and make sure that you have enough amps on your charger, because that could be why you're struggling, especially because the Pi 3B Plus is so power hungry. It asks for a 2.5 amp or 2.5 amp supply. So I would look to that and see if that's the cause of your issues.
And also check your USB cable, because cables are rated at different power as well, which you may have run across a different version of when your cable didn't do data. They can also be power rated differently. So check your cable, check your plug, and then check the other things on the list that we posted on Twitter.
Yeah. And I think that is going to about do it for our skill builder on the Raspberry Pi. I hope that this has given you some confidence to tackle some of the next Raspberry Pi project. As far as like whether you're deciding what board to use for a project you want to do, people are always asking the question of like, should I use a Raspberry Pi or should I use something like an Arduino? There's a very simple thing that people came up with. I don't quite like it, but it's the best description I've heard, which is, do I need my thing to do X and Y? Or if you have more than one and, then you should be looking for a Raspberry Pi to do that. Like if I needed to do this and this and this, rather than this and this, then you should look for a Raspberry Pi.
And also there is the option of using both together. There are several builds which will build on the strengths of both system and integrate them together, and we're going to talk more about that on the next Make Live.
Yes, and the other consideration mostly is like, does the project need to do advanced computation? In the case of, the dashboard computer, the skimmer scan that I was talking about earlier, I actually needed this to actively do Bluetooth scans and process the data. And that was something I originally was looking for the Adafruit, Bluefruit devices, and they can scan for what's called Bluetooth beacons, which is stuff I haven't really come to understand just yet, but I think they're just little devices that just ambiently spew out Bluetooth data, almost like little data waypoints. But this needed to actually look for Bluetooth devices and process that information. And for that, I needed an actual computer. So that's why I went to the Pi Zero for that.
A lot of times in vision projects where it's both seeing from the camera and then analyzing that, you'll want to put that onto a Raspberry Pi for the analyzation aspect.
But again, we were talking about the next project, and it's time to talk about what that is. We're not going to be building that. We're going to be building that on the next Make Live in May. But we're going to be taking this little tiny computer and installing what's called a Plex server. Plex is basically a media warehouse service that takes all of your media content, TV shows, movies that you have stored on a hard drive and makes it available so you can watch it on your TV set-top box. You can broadcast it to your mobile phone. As long as it's connected to a network, can then be accessible anywhere you have a web browser, and it just keeps your entire media library of movies, TV shows, music, photos, and just makes it accessible anywhere. And you run it just off of this tiny little computer that doesn't take up much power. That's one of the other great things about it is you don't mind running it in your house 24/7 because it's not going to use a ton of electricity. So that's what we're going to be building next. Once again, we want to thank our friends at DigiKey who make this series possible. If you missed the start of the show, DigiKey is a distributor of electronic parts and components, all the way from discrete components like LEDs and resistors, all the way up to things like this, the Raspberry Pi and Arduinos, and they sell everything. They ship super fast. I think at one point I realized they needed a part tomorrow around this time today, and it was on my desk the next day, literally within like 12 hours, which is amazing because they're in the middle of the country here in the U.S. They're in Minnesota, I believe. Some cool place called Thief River Falls, which is about the coolest town name I've ever heard of.
And I believe we have a link where you can get a Raspberry Pi in the info, the shopping cart.
I don't believe so now, but I think if you just go to digikey.com and look for Raspberry Pi, of course you'll be overwhelmed with options of all the different types of stuff that you... In fact, actually, let's take a quick look at DigiKey, because they have a... If I'm honest, they're set up my computer. They have... their search is very powerful, but I would consider it to be endemic of, like, if you're looking for hardware, like, it reminds me of, like, the McMaster car search. Let's pull up a web browser.
And there are a lot of options when you go to get a Raspberry Pi. That's because, like we talked about before, people bundle things with it. It's a good idea if you can afford to get a kit, because then you know your power supply is rated correctly for the board that you're purchasing. It comes with a lot of little extras that will help you with your projects and setups.
Yeah. So, yeah, we get these the sort of top results. Let's see if I can make this.
Swap cameras, though.
Oh, I certainly should. Thank you. And I should also see about making this larger. Yeah, there we go. And see this text a little bit better. And so you get all these listings in here. We get a lot of different things, but we're going to go to evaluation boards. And you get all these different ways of filtering things. But here we see, here's the Raspberry Pi 3. That's the one we were taking a look at a little bit earlier. Well, they only have 4,905 of them.
That may not be enough for our needs.
But that just means those are the ones they can ship immediately. They will get more. This is where we do see that, DigiKey does take a little bit of a cut for stocking them. So their price for it is $40. But still, it's a pretty impressive, incredible computer that you can get for $40, and you can do all kinds of really cool stuff with it, like build a Plex server, or a robot, or a retro gaming system.
And if you notice, these Pis are very not necessarily easy to put into your house if you want to like run all your stuff off of it. So they make a lot of cases and different accessories you can get to make it prettier or fit into your home well. And you can get those a lot of times with those kits as well.
If you have a 3D printer, you can also look on Thingiverse. There are tons and tons of different designs for 3D printed enclosures. One of my favorites is this sort of slip enclosure that it's just sort of a sleeve that your Raspberry Pi just slides right into. There's a little cover plate to cover up the ports here, but I don't generally worry too much about that. And that's really good to do because if you look on here, you notice that there's a lot of really exposed solder points, and if you ever put this on a conductive surface, those can bridge those and they can mess up your Pi real bad. Don't do that.
And then the other thing is that if you, like Tyler, are very talented at 3D modeling, the files and measurements for all this stuff is public and out there. So you can model your own cases in Fusion 360 or the software of your choice.
Yeah, and again, the nice thing about the Raspberry Pi form factor not changing much is that the designs files that have been around for a while will work with the most modern Raspberry Pi, or at least, I mean, I'm sure they'll probably release one at some point that will prove me wrong, but I hope not because they've been sticking with this form factor for a while, and you know, it hasn't changed. That means that old design files work with new hardware, and that is great.
Yes, and those are, you can 3D print them, you can laser cut them, you can even CNC them. I think you've CNC'd a case for it before.
I've never CNC'd a case for.
I thought I remembered a really nice wooden case.
Adafruit did that.
Oh,
right. The guys who do their layer by layer videos made a beautiful wood and acrylic and even laser etched case. Check it out; it's beautiful. And with that, I think it's time for us to talk about all the cool stuff that we have going on with Make. The most important of those, of course, is Maker Faire. Maker Faire is it's the greatest show and tell on Earth.
The greatest show and tell on Earth. Maker Faire Bay Area is coming up in May 18th through the 22nd in San Mateo in California. And
if you're local, please come out to that.
Come see us.
If you're not local, we have good news for you because our friends at DigiKey is sponsoring a live stream of what I mean, you can only see so much at Maker Faire because there's tons and tons of stuff. There's more. If you spent 5 days there, you probably couldn't see everything there. Unfortunately, we only have 2, but I'm going to be trying to curate a list of the cool stuff there and going to be bringing it to you. So if you only have the ability to watch from your home, we're going to do the best job that we can to present that to you.
And you can find it here on YouTube?
It'll be here on YouTube.
Here on Facebook?
It'll be either here or on Maker Faire on Facebook. So if you prefer to watch the stream on Facebook, make sure you like both pages, Make a Magazine and Maker Faire.
And we have makerfaire.com/livestream, correct?
Makerfaire.com/live.
/live. And the stream will also be embedded there, so if you can't remember which Facebook, which YouTube it was on, you can come find us there.
Yeah. And if you are there, well, again, DigiKey is also our partner with that live stream. They make it possible for us and do a great job of making that possible. They also are sponsoring the Make Electronics stage, so if you are there in person, they have a bunch of great talks that you absolutely shouldn't miss. Actually, you can see those live there or on the live stream, and some of the stuff that they make sure you don't want to miss is Ali Weber, who is
Technally Speaking?
Yep. She's also on Twitter at Robot Maker Girl, and boy, she just had a really wonderful tweet just a few days ago about kind of the whole maker ethos that's like, look, I don't know anything, or I don't know everything. You're probably going to be an expert on, I'm going to be paraphrasing this, but it's, yeah, you're going to be smarter about some things, I'm going to be smarter about some things. That's great, because that means that I can learn from you, and you can learn from me, and, you know, it's not important that I know everything, and I'm never going to be good at everything, because none of us ever can be good at everything. And that's not really what we're trying to do here. We're just trying to be good at a couple of things.
And help each other be good at things. That's my favorite part of that tweet.
Anyhow, follow her on Twitter. She's awesome to follow. Go find that tweet and like it, because it is the best tweet I've read in a while. Anyhow, other stuff, other people are going to be on the
Make Electronics
stage is Sean Jordan, who is the Associate Professor of Engineering at the Ira A. Fulton Schools of Engineering. And
we have Sean Himmel, who is the Spark Fun Electronics Engineer.
That'll be a good one to see. Also, before Maker Faire, because we can't cram everything into just those 2 days, we have our entire week of learning.
And that is really exciting. It lasts from Saturday the 12th all the way until Friday, May 18th. It's going to have workshops and cool things to do all over the Bay Area. There's the Space Leadership Unconference, which is for makerspace leaders to gather together and share tips and have talks about how to set up makerspaces, how to run them in schools, libraries, creative makerspaces, local makerspaces. There's the super fun Maker Block Party, which is 4 family workshops on robotics, tinkering, printmaking, and stencils. And there are all kinds of things on blacksmithing, soldering, learning Fusion 360. You can check it all out on the makerfair.com website.
Also, if you are here in the Bay Area or you're coming to Maker Faire and you're coming to Maker Faire early, and you're here Thursday evening, do try and make it out to Maker Faire After Dark or Exploratorium After Dark Maker Faire Edition. Is that what it's called?
I believe it's After Dark Maker Faire.
Okay. So the Exploratorium is a science museum that's been here in San Francisco for years and years and years. It's been my favorite science museum since I was a kid.
Same.
All of their exhibits there are hand-built exhibits that you get to interact with to understand different scientific phenomena. All the stuff there, all the exhibits there are made in their workshop, which is right next door. In fact, part of the workshop is actually part of the museum, so you can actually see people building exhibits. They do these events on Thursday evenings. It's called After Dark, and the one right before Maker Faire is going to be the Maker Faire Edition one.
Now, this is adults only. We're sorry, 18 and up. Tickets are available online at exploratorium.edu. They're $17.95 ahead of time and $19.95 at the door. And again, that's Thursday, May 17th from 6 until 10.
It's all adults only because you can buy beer.
Yes. But if you are under 18 or near 18, the next day on Friday is the ICC Industrial Career and College Day at Maker Faire. And this is hosted in partnership with Cornell University College of Engineering. It's designed for upper-level high school students and college students to explore career paths, education, job opportunities related to making, IoT, tinkering, robotics. There's going to be a whole bunch of speakers and great stuff.
Moving on beyond that, we have some other cool stuff at Maker Faire that I want to make sure people know about. We're having our first annual Maker Faire prop contest and cosplay contest. Where, this is one of the things I've been feeling is we get people every now and again who come out to Maker Faire in cosplay outfits, but I think it's been really missing on a grand scale because nearly all of the maker disciplines are needed to build these amazing costumes by amazing people. And of course we have people out there like Bill and Britt Duran, and a couple of other popular people in the cosplay community are going to be a part of that. And we hope to see you out there, of course, in costume, although I hope you're already started working on them because these take a while. Although if you got to see our friend Daryl Maloney, he recently did a cosplay walk with Adam Savage at Silicon Valley Comic Con. I think they built the bulk of those costumes in a week.
Wow.
Which is incredible. Well, I think Daryl 3D printed a lot of parts ahead of time and brought them out there. There's a video on Tester.com. Go check it out.
And so if you want to enter our prop contest, it is available on makershare.com. The deadline to enter is May 6th, so you should get your build together now. Go put the build up on Makershare, give us all the great details, and then we're going to go through those builds, and we're going to invite the winners to come on stage at Maker Faire Bay Area and demo their cosplay prop.
Yeah. Another part of Maker Faire that I'm really excited about is we're calling the YouTuber content creator stage. And that's where we're inviting a bunch of our friends from the maker community here on YouTube out to talk on stage. So you're going to be seeing folks like Bob Claggett, David Picciuto, Wes Swain from Geeksmithing, Laura Kampf. Who else is on there? A little guy you might have heard of called King of Random, Grant Thompson. He'll be there. Electro Boom, a whole lot of other people that we're really excited to meet or see again because they're friends of ours, and go give awesome talks. Joel Telling, the 3D printing nerd, Paul Jackman, a lot of awesome folks that we can't wait to have them showing off all the cool stuff they do. We talked a little bit about Make Magazine Volume 63. This is our annual boards guide.
Boards guide!
So everything from Raspberry Pi to Arduino, everything that is a piece of hardware that you need to build your project. This is the magazine that, if you are interested in that stuff, this is the magazine you should pick up.
And we have all kinds of goodies in this issue for you. There's great projects based around the boards. There's a whole bunch of specs for you to get into and analyze. And it's just a really wonderful issue.
And yeah, and this is also a magazine, a considerable portion of it is made possible, again, by our friends at DigiKey.
And if you couldn't join our cosplay prop contest, but you really love Make Magazine and you want to be in it, you should see the mission to make on makershare.com, which is if you enter your project, a project will be chosen from that to be featured in an article in Make Magazine. So you should, the deadline for that is May 18th. Go enter now, and maybe we'll see you in the next issue of Make.
And a couple last things before we go. There's a couple new things in the shed, themakershed.com, one of which you already talked about, which is the game frame. If you like that, you can get your own. And the other one is, I just made a video about it. It is the GoPi Go 3. It's a Raspberry Pi based robot kit with a ton of different programming options. You can use block-based programming or Python and build a robot based on a Raspberry Pi. And also one thing that it was a surprise to me that I just learned about is that we are finally publishing a Fusion 360 book. I'm super excited about this just because I felt like that's been a gap in our learning for a while. And also, I'm excited and terrified to read the book because Fusion 360 is a piece of software that I use for design for 3D printing or CNC work. I've been largely learning on my own, and I'm excited to learn more and terrified to learn that I've been learning to use it completely the wrong way. But, you know, sometimes that happens.
And that's by Lydia Sloan Klein. That's Klein spelled C-L-I-N-E. And you can pre-order it on Amazon.com if you look up Fusion 360 for makers, and it is $28.49.
Great. And well, I've been thanking DigiKey a lot, but we can never thank them enough because they're awesome. So thank you, DigiKey, for allowing us to do this stream. We did get one more note for another thing to make mention of.
We did already mention the missions.
Okay, we did. All right. And with that, thank you so much for joining me on the stream today. Thank you guys for sticking with us and asking awesome questions. And I really hope this has been helpful to you to kind of learn some of the basics of working with a Raspberry Pi. Also sticking with us through that lull in the middle or at the beginning when we had to install some software because I broke the software. Sorry.
It's a real-world troubleshooting experience.
Anyhow, thank you very much for joining us, and we will see you next month when we get to build a Plex Media server on a Raspberry Pi.
Should we stop the Facebook?
Do the ad.
Now remember what I told you.
Yeah, don't make eye contact. He takes it as a personal challenge.
Hello? Pat?
Yes.
Can I get a,
He'll take a Raspberry Pi 3.
No pie for you.
Told you. Hey, but I did hear this new deli. I can go pick up the sandwiches.
Don't be held hostage by the board order. Go to digikey.com to find thousands of boards in stock, all ready for immediate shipment.